This is section 6.3, and we're going to talk about the domain of trig functions. It's not a really long section, so it shouldn't be too bad. So these, I've put the domain information here. The domain of the sine and the cosine is all real numbers. That's a function that goes on and on and on and on like that. If I were drawing it, it just does this on and on. And so the domain is all real numbers. Now, tangent is all real numbers except odd multiples of pi over 2. So it looks something like that, but in here there are some asymptotes, and so every odd multiple of pi over 2, you you have a restriction. Okay. The domain of the secant function is the set of all real numbers except odd integer multiples of pi over 2. Now, cotan goes the opposite way. It looks kind of like this, but goes the opposite way, and it is the all reals except integer multiples of pi. And the same thing for cosecant. So cotan and cosecant have the same, and tangent and secant. So if we look down here, we've got information about the range. So for sine and cosine, the domain is all reals, but the range is from -1 to 1. So it's restricted. It doesn't live below here and above here. So this is at 1, this is at -1. So that has a restricted range. For tangent, the range is all reals, and you could see that it goes up forever, down forever. So all real numbers. And cotangent would be the same thing. The range is all real numbers. Cosecant and secant, they actually live up here where that actually would touch that. And so they have these pieces that do that. That would be your cosecant and secant. And so you could see that all real numbers less than or equal to -1 or greater than or equal to 1. So where sine doesn't live above 1, secant starts at 1 and goes up, and starts at -1 and goes down. So that's a really nice chart that talks about the range. And then you have your domains here. So that's just the information. For periods, tangent and cotangent have a period of pi. The others have a period of 2 pi. We also talk about reciprocal identities, which I've mentioned a little bit. Cosecant is 1 over sine, secant is 1 over cosine, cotan is 1 over tan. It would be worth your while to start learning those and remembering those. Tan is sine over cosine, cotan is cosine over sine. Then we have Pythagorean identities. There are those. We have some even odd properties that you need to work on. Cosine and secant are even functions, and the others are odd. Now, there is a handout that has all your trig identities and rules. It would be worthwhile to print that from handouts and start learning some of those. That will be really important. And if you're going on to calculus, it's really important to know your trig. All right, let's go look at our problem set. Number 1, complete the sentence. The sine, cosine, cosecant, and secant have period of 2 pi. The tangent and cotan have a period of pi. And what that period means is how long does it go before it starts repeating? So for the first 4 that were mentioned, it goes a full unit circle, 2 pi, before it starts repeating. But the tangent and cotangent only go 2 pi. The domain of the tangent function is, and we could go back and look at our notes, but it's all real numbers except odd integer multiples of pi over 2. Which of the following is not in the range of sine function? Well, so that's in it. That's in it. 1.5, that's above 1. This would be pi over 4. So it has to be -1 to 1. That is not in the range. Sine squared plus cosine squared, that was one of those Pythagorean identities, and that's equal to 1. Determine if this is true or false. Secant theta equals 1 over sine theta. That's false. If we go back to our notes, and we go down here, the reciprocal identities are here. And I used to learn these and remember them by C goes with S goes with C. So secant would have to go with cosine. That's one way you might think about it. So that one would be false. That's S and S. Use the fact that the trig functions are periodic to find the exact value. So 405, well, if we know the period is 2 pi, so if I subtract 360 from that, I am at 45. The cosine of 45 is square root of 2 over 2. Tan of 390, well, if I take 360 from that, I get 30. I did that here. So tan of 30 is square root of 3 over 3. Cosine of 13 pi over 6. Well, remember, I'm taking 360 away or 2 pi. So 13 pi over 6 minus 12 pi over 6 equals pi over 6. Cosine of pi over 6, or 30 degrees, is square root of 3 over 2. Use the fact that these do not use a calculator. Okay, so we're doing the same thing. Secant of 7 pi over 3. So I'm taking away 2 pi over 3. I'm taking away 2 pi. So that is 6 pi over 3. Have to do a little conversion for your fractions here. So that leaves me pi over 3. And the secant is 1 over cosine. So you would look at what cosine of pi over 3 is. That's 1/2. And then the secant would be a flip of that, so you get 2. Name the quadrant in which the angle theta lies. Okay, so where is sine theta negative and cosine theta positive? Well, sine is negative in quadrant 3 and 4. Cosine is positive in 1 and 4. Where's the overlap? That's quadrant 4. And remember, we kind of talked about that in the other notes on the unit circle, where it said ASTC, and you can figure out where things are positive and negative. So that will be important to start learning. Okay, so that's a repeat. I don't know why that problem's there, but it is a repeat. So that would be quadrant 4. All right, name the quadrant in which this one lies. Where is cosine positive and cotan negative? So cosine's positive, quadrant 1 and 4. Cotan's negative, quadrant 3 and quadrant 4. The overlap is 4. 13. Sine and cosine are given. Find the exact value of the 4 other functions. So sine theta is 7 over 25, and cosine theta is negative 24 over 25. So that means you are negative in the cosine area, positive in the sine area. So come out from the origin, draw your angle, drop your perpendicular. So this is your triangle. So if sine is 7 over 25, cosine is negative 24 over 25. Now that we've got that drawn, cosecant is 1 over sine, so that would flip that one. Secant is flipping the cosine, so we do that one. Tangent is opposite over adjacent, so that's negative 7 over 24, and cotan would be the flip of that. So I think that should get you going using the domain and the range and some of the reciprocal identities.